Hello. Should hear me now. Can you confirm that you can hear me? Hello. Right. Perfect. Right. So today I have 6 problems for you. Some of them are quite basic, and the last one is quite challenging in the way that I'm going to do it. Okay, so the last problem is not necessarily best done with the coordinate method, but I just wanted to show you how you can use the coordinate method for pretty much any problem. Okay, so we'll start with the first one. So I'll share my screen and share. Okay, brilliant. Oh, just need to see the chat. Just to see the chat. Chat. Okay, perfect. In a parallelogram OABC, O is 0, 0, A is 3, 6, B is 8, 6. Find the ratio of the lengths of the diagonals OB and AC. Okay. So we'll start by drawing the coordinate system. So this problem is phrased in the coordinate language. So it's fairly easy to apply a system of coordinates. So we have X and Y. And OA is 3, 6. So 3, 6. B is 8. So it's 3, 6. B is 8, 6. Oh, that makes life easier. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 8, 6. B is 8, 6. And O is 0, 0. O. And very obviously, you can find the point C, sorry. So point C would be the same distance from O as A. We just need to figure out which way. Can it go left? Well, not really, because it's OABC. So OAB, so C has to be somewhere here. There's no option to put C here, for example, yeah? Because BC has to be parallel to OA. So it can either go this way or this way. You can't place a point C here, so C has to be here. So C has coordinates 1, 2, 3, 4, 5. C has coordinates 5, 0. And here's our parallelogram. Okay, so that was fairly simple to do. And now diagonals OB, and you know what? I'll ask another question. What is the angle? What is the angle between the diagonals? Diagonals OB and AC. It's an extra question. Just came into my mind. So let's draw the diagonals. So AC and OB. There are very many different ways you can do it. You can just find the distance between the points. Oh, absolutely. Yeah, finding the distance between the 2 points is just so AC is, sorry, the length of AC. AC is the square root of 5 minus 3. 5 minus 3 squared plus 0 minus 6 squared, 0 minus 6 squared. And that is square root, that's 4 plus 36 square root of 4, square root of 40. Square root of 40. And OB, this is 86. OB is so square root of 8 minus 0 squared plus 6 minus 0 squared. That is 8 plus 6, so 64 plus 36, so it's 10. So, and the ratio of the length would be of OB to AC, OB to AC, OB to AC would be 10 to square root of 40, square root of 4, square root of 40. Well, you can simplify that as 5 to square root of 10. That's pretty much it. And find the angle. Well, the angle, there are many different ways. So, for example, you could use you can use the cosine rule. You can use the sine rule potentially to find the angle. I'm going to use vectors. So I'm going to write down the vector AC. AC is C minus A. So it's the radius vector of point C minus the radius vector of point A. And that is 5 minus 3. So 5 minus 3 and 0 minus 6. So that is 2 minus 6. So vector AC is 2 minus 6. Vector OB is radius vector of B minus radius vector of O. Okay, minus radius vector of O. And that is 8, 6. 8, okay, I'll write it down. 8 minus 0, 6 minus 0. So it's 8, 6. 8, 6. And then to find the angle, we do to find the angle, I say the angle between AC, the cosine of the angle between AC and OB. It comes from the scalar product. Yeah, so let me write this down. So AC multiplied by OB is the modulus of AC times the modulus of OB multiplied by cosine of the angle between them, AC and OB. And the cosine is equal to this scalar product, AC, OB, divided by modulus AC, modulus AB, which we already have. So we just need to calculate the dot product. So the dot product is going to be, so we dot product these two vectors. So it's going to be 2 times 8, 2 times 8, and minus 6 times 6. 6 times 6. And here we have the lengths. So AC is square root of 40, and OB, sorry, OB is 10. So, and that is 16 minus 36. So it's minus 20. Square root of 40 times 10. So 20 and 10 cancels. 2 square roots of 10. So it's minus square root of 10 over 10. And then we do, so the angle that we are looking for is our cos of minus square root of 10 over 10, which is something. You can usually leave the answer like this. So if it's a math question, the answer r cos of minus square root of 10 over 10 is a valid answer. Although I will calculate, and it's 108 degrees. 108.4 degrees. So yeah, fairly straightforward. There are many other ways in which you can do. Yes, cosine rule, for example. What else? Well, you can find the equations and use the gradients to figure out the angle. But I've chosen one of the easy ways, I guess. Sometimes you will be asked to find the acute angle. So obviously you found this. This is 108. This is 108 because it's the angle between OB and AC. OB has a direction, AC has a direction. You found this angle. You can find this angle by subtracting 180. So 80 minus 108 is 72. 72 degrees. Okay. OCBA is a trapezium. That's problem 2. CB is 6, OA is 10, angle COM is 60 degrees. Okay, that's 60 degrees. Find the equations of the sides of the trapezium. Well, there's it all comes down to just finding the coordinates. So A is 10, 0. Now we know that CB is 6. OA is 10. Oh, sorry, that doesn't make any sense. The angle is 60. Oh, okay. So this is 10. So this is 6. And the whole thing is 10. So this must be 2. And this must be 2. And if this is 2, then you can find CM. CM divided by OM is equal to tangent of 60. Sorry for the handwriting. CM over OM. Yes. So CM is equal to OM tan 60. And we know that OM is 2. And tangent of 60 is square root of 3. So 2 square root of 3. So C has coordinates 2 and 2 square roots of 3. And this has plus 6, so it's 8 and 2 square roots of 3. Once you found all the coordinates, everything else becomes dead easy. So line, let's start with the easy ones. Lines OA. Line OA has equation y equals 0. Hope that is obvious to everyone. If not, ask me, please. CB has equation CB has equation y is equal to 2 square roots of 3. Now OC is a line through the origin, so the y-intercept is 0. And remember that the gradient is equal to the tangent of the angle. And since we know the angle, it becomes super easy. So for OC, it is y is equal to tan 60 multiplied by x. This is because m is tangent theta. That's an important thing to remember. So it simply means that y is equal to square root of 3x. All right, to find BA. Well, we know the angle. We know the angle that it makes with the positive x-axis, and the angle is 120 degrees. This is 120 degrees. So we can use the formula y minus y0 equals the gradient m x minus x0. So y minus 2 square roots of 3 equals the gradient. The gradient is tangent 120. Tangent 120. 90 multiplied by x minus 8. And all we need to do is simplify this. So y is equal to tangent of 120 is minus square root of 3, minus square root of 3x, minus plus 8 square roots of 3, plus 2 square roots of 3. So y is equal to minus square root of 3x plus 10 square roots of 3. That's it. These are the 4 equations that we were looking for. Is there anyone here who doesn't understand? Yeah. Is there anyone here? Any part of it? Any part of it? Okay. Of course, you can use for AB. You could use the formula of a line going through 2 points, and the equation looks like this: x minus x, sorry, y minus y1 is equal to y2 minus y1 divided by x2 minus x1. This is quite a fascinating one, actually, because what it does, where does this equation come from? If you have 3 points, 2 given points, x1, y1, that's a given point, and another given point, x2, y2. So imagine you have 2 given points, and any point on the line, xy, has to satisfy this. So what does it say? Well, actually, what it says that let's call this A, call this B, and call this C. So the gradient of AC has to equal to the gradient of AB. So the point xy lies on this line only if this is true, if the gradient of AC equal to the gradient of AB. And the gradient of AC is equal to y minus y1 divided by x minus x1. And the gradient of AB is equal to y2 minus y1 divided by x2 minus x1. And this is a quite a cool formula to use. If you modify this, you can see that this is the gradient. This is the gradient of the line. So y minus y1 divided by x minus x1 equals the gradient. So y minus y1 is equal to the gradient x minus x1, another familiar formula. So they're all interlinked. Okay, coming back. Find point A on the line which is equidistant from B and C. Find the area of the triangle ABC. Okay, so here we don't necessarily have to do a coordinate system. We can just draw, because it's a bit of a hassle to draw this line. So I'm gonna make my life easier and just say, okay, there's a point on the line A which is equidistant from point B and point C. So B, apologies. B is -2, -3, and C is 4, 1. And what I do know is that AB is equal to AC. B is equal to AC. Okay, let's say that A has coordinates x and y. And we can just write it down. We can say that the distance AB is equal to AB squared, just for the sake of it, AB squared is equal to x plus 2 squared plus y plus 3 squared, and AC squared can be written as x minus 4 squared plus y minus 1 squared. And since they are equal, we can write that x plus 2 squared plus y plus 3 squared has to equal to x minus 4 squared plus y minus 1 squared. I'm going to stop typing. We expand x squared plus 4x plus 4 plus y squared plus 6y plus 9 equals x squared minus 8x plus 4 plus 16, apologies, plus y squared minus 2y plus 1. X squared and y squared cancel out. We got 4x plus 6y plus 13 has to equal to minus 8x minus 2y minus 8x minus 2y plus 17. Or in other words, 12x plus 8y, 17 plus 13 plus 30 plus 30 equals 0. So what we do know that the points of that the point A lies on this line. And it's not really a coincidence. What we actually got, if we got the equation of the perpendicular line, we got the equation of the perpendicular bisector of line BC. We could have obtained it in a different way. But we said that A, so xy, is a point which is equidistant from B and C. The definition of points that are equidistant from B and C is the perpendicular bisector. So this equation has, this line has equation 12x plus 8y plus 30 equals 0. Can we simplify it? Yeah. It is, yes, sorry. Minus 4, of course. Thank you. I'm glad that you're paying attention. And of course, it can be simplified to 3x minus plus 2y minus 1 equals 0 divided by 4. So that's 3, that's 2, and that's 1. Okay. And then all we need is just to find the point of intersection of the two lines, which is of the line of this line, which is 5x minus 2y plus 9 equals 0. Okay, I'll try not to embarrass myself by making a silly mistake. Adding the two equations, 8x. Adding the two equations, we get 8x plus 8 equals 0. So x is minus 1. And plugging it into the second equation, so 2y equals 1 plus 3. So y is 2. Y is 2. So this point, A, is 1 minus 1, 2. Any questions? Any questions here? Okay, and find the area of the triangle ABC. Well, since we established that this green line is the perpendicular bisector, then it becomes quite easy to find. We just need to find the midpoint of BC. We find the midpoint of BC, label it M. And it's this plus this, so it's 1. This plus this over 2, so minus 2 divided by 1, minus 1. And so AM, so AM squared is 1 minus minus 1, 1 minus minus 1 squared, plus minus 1 minus 2 squared, which is 2, and so 4 plus 3 squared, 9. which is 13, and BC squared BC squared is 4 minus 2, 4 minus 2 squared plus 1 minus 3, 1 minus 3 squared, which gives us 6 squared, 36, plus 4 squared, 16, which is square root of 52. Sorry, 52, because it's a square, 52. And the area is 1/2 base times height. Base is BC, and height is AM. So it's 1/2 multiplied by BC, which is square root of 52, and multiplied by square root of 13. 52 is 4 times 13. So it's 1/2 times 2 times 13, and the answer is 13. Okay, so let me just write down the answer. Answer A is -1, 2, and the area is equal to 13. Okay, problem 4. So getting to more interesting stuff here. In a triangle ABC, A is 2 minus 1, B is -3, 5, M is 1, 1, is the point of intersection of the median lines. Find the coordinates of point C. So once again, in this question, it's not necessary to draw them accurately. Draw them accurately on a grid. So I'm just going to draw a random triangle and say this is A with coordinates 2, -1. This is B with coordinates -3, 5. And M is the point of intersection of the median lines. Okay, whatever that is. So the median line, you probably know that it connects the vertex to the center of the opposite side. Median line. So bam, bam, bam. Okay, so this is C. Let's say the coordinates of C are unknown. So let's label them as X and Y. Why not? This point M has coordinates 1, 1. Okay. Any ideas how to proceed from here? Give me a hint. There are many different ways you can do. Some ideas, maybe? D. What is D? Distance, which distance? From what to what? PQ. Find the midpoint of AB. Then line that goes to the midpoint of AB and the midpoint of AB and M. Okay, that's a great idea actually. So let's label this P, Q, R, and R is the midpoint of AB, so that's easy. That is 2 plus minus 3, which is -1 over 2, so -1/2. -1/2. And then -1 plus 5, which is 4. 4 divided by 2 is 2. -1/2 and 2. Okay. And you got an equation of, then you say find the equation of Rm. Oh, potentially, yes, you could find the equation of Rm. There is actually a much easier way. Maybe introduce vectors. What do we know about Rm and MC? What do we know about Rm and MC? Or what do we know about the point of intersection of median lines? If you remember, it's this from physics. The point of intersection of the median lines is Rm is 1/3 of RC of M. Not quite. Close. You're very close. 1/3 of RC is Rm. That is true. Yes, absolutely. So well done. It's, if you remember from physics, it's the center of mass of the triangle. Center of mass of a triangle at the point is intersection of medians, and it's 2/3 of the way from the vertex to the opposite midpoint. So Rm, in fact, is 1/2 of MC, not 1/3. Yeah, Lizzie, you were close, but it's 1/2. So the ratio is 1 to 2, and that's great. That means that we can find MC. MC is the vector MC is 2 times the vector 2 times the vector Rm. 2 times the vector Rm, so 2 times the vector Rm, and Rm is 1.5, 1.5, and -1. Okay. Is there someone who doesn't understand why vector Rm is 1.5 minus 1? Please don't be shy. It's okay not to understand. Hopefully, if you've done the assignment 1, you remember what happens here. So 1.5 and -1. So the vector MC is 3 minus 2. Vector MC is 3 minus 2. And okay. Then to find point C, we also know that vector Cm is the coordinates of C minus the coordinates of M. So X, sorry, not Cm, MC. MC is the coordinates of C minus the coordinates of M. I'll write this down. Is the radius vector of point C minus the radius vector of point M, which is x minus 1 and y minus 1. And because this is MC and this is MC, we just make them equal. So x minus 1, y minus 1 is equal to 3, 2, 3 minus 2. So from here, it's quite easy that x is 4, y is minus 1. Okay, and just to emphasize, the point of intersection, of median lines is the center of mass of the triangle, and also it splits the medians in the ratio 2 to 1, counting from the vertex, measuring from the vertex. All right, lovely. Oh well, we're almost to question 5. We might finish a bit earlier today. It's not the most difficult topic in the world. Sorry, it's not the most difficult topic. Just need to be careful in some places. Apologies. Too many requests. Oh, quite a few of you today. That's great to see. Right, got some connection issues. Apologies. Okay. Okay, it should work now. Is it working? No. All right, let me check if I have a backup scenario. Okay, the question is very hard to see. Apologies for this. Server is overloaded. Okay, so problem 5, I'll type it out. A circle is inscribed in a square. Prove that the sum of the squares of the distances inscribed in a circle square inscribed in a square, point M is on the circle. Prove that the sum of the squares of the distances from point M to the vertices of the square does not depend on the choice of M. Choice of the point M. Nothing here. Right. So that's problem 5. So we have a circle inscribed in a square. Point M is on the circle. Prove that the sum of squares of this. So nowhere here do you see here a mention about any coordinate system whatsoever. But that's not a problem. You can always introduce one. So what I'm going to do is I'm going to introduce a coordinate system. And introduce a coordinate system. This is going to be X, Y, and this is X. The circle, I'm going to place the circle in the center. Doesn't really matter where you put it. It's just a matter of choice and a matter of how difficult the calculations are going to be. So place the circle in the center. Okay, and let's say that the radius of the circle is A. That means that the equation of the circle is x squared plus y squared equals a squared. Okay. And we know that the circle is inscribed in a square. Is inscribed in a square. And so this point has coordinates A. This point has coordinates minus A. This point minus A. And this point is A minus A. There's a point M. There's a point M on the circle. M. And let's say the coordinates is X, Y. And of course, we know that the coordinates of M satisfy this equation. We just keep this in the back of our heads. Prove that the sum of the squares of the distances, so we're talking about this distance. Let's label the points. Let's label this A, B, C, D. So MA, MB, MC, and MD. that the sum of the squares of these distances does not depend on the choice of point M. Okay. So what we need to find is AM squared plus BM squared plus CM squared plus DM squared. We also need to find this sum. Okay, so let's start with AM squared. AM squared is the distance. Well, x minus a squared plus y minus a squared. Fairly straightforward. You could do a minus x and a minus y. It doesn't really matter because a minus b squared is absolutely the same as b minus a squared. Yeah, so it doesn't matter which way you go. AM, BM squared is going to be x minus a squared b minus a, x minus plus y plus a squared cm squared. Okay, there's going to be a lot of writing here. X plus a squared plus y plus a squared, and dm is going to be x plus a squared plus y minus a squared. Okay, so from here is just algebra. Nothing closely spectacular here. So the sum of squares of sides, the sum of these, I'll just call it sigma. Sigma is equal to. We expand them all. So the first one, am squared, so is x squared plus, apologies, minus 2ax plus a squared plus y squared minus 2ya plus a squared plus, I'm going to go in a new line, so plus x squared minus 2ax plus a squared plus y squared plus 2ya plus a squared plus, this may look scary, but it's actually not, plus a squared plus y minus plus 2ya plus a squared plus x squared minus plus 2ax plus a squared plus y squared minus 2ya plus a squared. So what I've done is I've expanded all of these brackets and I've added them together. And as you can see that these cancel out, this cancels out, this cancels out, and this cancels out. And what you're left with is 4x squared plus 4y squared plus 8a squared. A squared. Remember, a is the radius of the circle, and also a is half the side of the square. The square is the side of 2a. What do we do now? Well, now we need to realize that because point M is on the circle, its coordinates satisfy this equation. So since M belongs to the circle, M is on the circle, that means x squared plus y squared is a squared. So from here, the sum is 4x squared plus 4y squared. So that's 4a squared plus 8a squared, which is 12a squared. So truly, the choice of point M does not matter. We have an answer which does not depend on x and y. Because for any point on the circle, this would be 4a squared. Aha. So it's alive. Okay, so here it is. And finally, the last question. Now, I have to say that the last question, I've mentioned this before, the coordinate method is not the best way to do this question. However, I am going to use the coordinate method. I'm going to cut some corners towards the end because the calculations, yeah, it took me 2 pages to do it. And okay, so a circle of radius 5 whose center is outside the square ABCD of side 6 passes through points B and C. Find the acute angle between the tangents to the circle drawn from point D. So a good diagram will help. We kind of need to decide. We need to decide where do we draw the circle, and where do we draw the draw the square? Well, to me, drawing the circle at a point other than the origin might be quite a hassle. So I'm going to put this circle at the origin, because why not? So draw the circle. Okay. Draw the circle at the origin, and the radius of the circle is 5. 4, 5. Brilliant. Okay, I can fix that. Now, the square. The square ABCD, so passes through points B and C. So we know that the side of the square is 6. So let's draw that square of side 6. And try to put it somewhere. Well, why not? Well, there's only one way of the circle going through the square. So, well, that fits very nicely. I mean, you can use the guidelines, that you use the squares to help you. Why not? And you can see that, well, we will confirm that, but it looks like the square fits quite nicely here. So 6 And this point should be 4, 3. So we will check that. So we'll draw this. We'll draw this and say, okay, this is 5. And of course, if this square is 6, so this must be 3. So by Pythagoras theorem, this has to be 4. This is, yeah, Pythagoras theorem. And this immediately gives us the points. So the points B and C lie on the square. So this will be point B. Oh, on the circle. Sorry, this is C. This is D. And this is A. A, B, C, D. So we can find the point C, which is 4, 3. We can find point B, which is 4, minus 3. We can find point A, which is 10 minus 3. And we can find point D, which is 10, 3. Okay. Now, it says find the angle between the tangents drawn from point D. So I'm going to draw tangents from point D. Okay. Then well, I need to find the tangents. If I know the point, I know one point. So if I find the gradient, I will be able to find the equation of the line. And also, if I have the gradient, I will be able to find the angles, because if you remember, the gradient is the tangent of the angle between the line and the x-axis. So yeah, so from here, I can see that I need the gradient. So how do I find the gradient? Well, I say that this point, let's say this point is an unknown, x and y. What do I know about this point? Well, I know, first of all, that x squared plus y squared is equal to 25. That's the first thing that I know about this point. Secondly, I know that this point lies on the straight line with gradient m passing through point D. Fair enough. So what do I know? Do I know about point xy? This is the question I'm trying to answer. Well, first thing, I know this. Secondly, I know that it is on the line passing through D with gradient m. It is on the line. I will type that just to be on the safe side. It is on the line of gradient m passing through D. So I'll write the equation of that line. That means y minus y0 is equal to m x minus x0. So y minus 3, which is the y coordinate of point D, is equal to m x minus 10, of course. Now, one more thing that I know, which is very important to this question, because it is a tangent. the only one point, only one common point, the tangent, the line and the circle have one common point. Line and circle have only one. Line and circle have only one common point. Yeah. So what I'm going to do here is there are two ways. I could either find the gradient of this point, of this line, and say that these are perpendicular because this is the radius, this is the tangent, and that means that I could I could use that fact. I'm going to use it. I'm going to go a slightly longer way. Because they have only one common point, that means that the equation that I write has only one solution. And if the equation has one solution, that means that the discriminant is 0. So from here, I can write that y is equal to mx minus 10m plus 3. Or I could write it as mx plus 3 minus 10m. This is just to make my calculations a bit neater because it's going to go a little bit crazy in a bit. Okay, so I have x squared plus y squared equals 25, and I have y is equal to mx plus 3 minus 10m. I can plug that in. I plug this in, I use substitution, and I can say safely that x squared plus y squared, so mx plus 3 minus 10m squared equals 25. This equation has one solution. Hence, the discriminant is going to be equal to 0. And I'm using because this is a tangent line, this equation has to have only one solution. Does that make sense? How much sense does it make on a scale of 0 to 10? Please answer in the chat. Good, perfect. Makes lots of sense. Brilliant. And now we just do lots of calculations. We expand the brackets to find the discriminant, because that's what we're looking after all. X squared plus m squared x squared plus 2mx 3 minus 10m plus 3 minus 10m squared minus 25 equals 0. And this is a quadratic equation. It's a quadratic equation. So A is equal to 1 plus m squared. B is equal to 2m 3 minus 10m. And C is equal to that. Well, I'm gonna open it up right away. So it's going to be 9 minus 60m plus 100m squared minus 25. So C is equal to minus 16 minus 60m plus 100m squared. Actually, makes sense to write it the other way around. Okay. And we know that the discriminant is b squared minus 4ac, which is b squared minus 4ac, so that is 4m squared 9 minus 60m plus 100m squared minus 4 1 plus m squared c, which is 100m squared minus 60m minus 16. So that's equal to 400 m to the power 4 minus 240 m cubed plus 36 m squared. Okay, minus 400 m to the power 4 minus plus 240 m cubed plus 64 m squared minus 400 m squared plus 240 m plus 64. Okay, so 400 m squared cancels, 240 m cubed cancels, which is very nice. 100 m squared minus 400 m squared is going to be minus 300 m squared. M squared, and then plus 240 m, 240 m, and minus plus 64. Okay, I've done it the second time and I got the same result, which is good. That means I haven't, well, that means I'm unlikely to have made a mistake. Solving this quadratic equation, as I said, I'm going to cut corners a bit. So solving this quadratic equation, we get m1, which is going to be 6 plus 2 square roots of 11 divided by 15, and m2 is going to be 6 minus 2 square roots of 11 divided by 15. So what did I find? Well, I actually found so this is approximately 1, or 0.001. So this is approximately 0, 1, 1. And this is approximately minus 0.211. So what did I find? Well, I found the gradients of the two lines. So M1 is the positive one. So the M1 is the gradient of this line, and M2 is the gradient of this line. Okay. So we have the gradients of two lines, and we need to find the angle between them. So we need to find this angle. We need to find this angle. Let's call it alpha. So to do this, we draw the we draw the horizontal line through here. And we know that this angle, θ1, is equal to arctan tan M1. Arctan M1. Now, we know that this angle, θ2, is going to be minus arctan tan. Well, okay, for the sake of it, I'm going to say arctan of modulus M1, arctan of modulus M2. I mean, here, so why is it modulus? Well, because it's a negative value, and if we do arctan of a negative value, it's going to be an obtuse angle. This angle is obviously not obtuse, and obviously, if you have the same gradient up and down, the same by modulus, this angle will be the same. So I just made my life a little bit simpler by taking the modulus. And alpha, of course, the angle that we're looking for is θ1 plus θ2 plus θ2, which is arctan of 6 plus 2 root 11 divided by 15 plus arctan. Well, because it's the modulus, and this is a negative number, the modulus of a negative number is minus that number. Minus 6 minus 2 root 11 divided by 15. And we know arctan is an odd function. So for an odd function, f of minus x is equal to minus f of x. So we can take the minus outside. So the minus is going to play outside. Yes, and that is it. I mean, we could potentially leave the answer like this, and this is approximately 57.2 degrees. 57.2 degrees. Okay, that is this problem. But I mean, what I'd like you to focus on, well, this bit, how I figured this out, and also well, how I played around with the square here to find the coordinates, of the square. And of course, the most important bit is that the tangent has one point of intersection, so I used the discriminant. So there's lots of stuff coming into one, which you can use to figure things out. Okay, so hope that was helpful to you. If there are any questions, please do ask. Otherwise, see you next week. We'll probably do a mixture of physics and maths next week.
Can I just quickly ask a question,
yeah.
please? So, like at the very end, when you found the two gradients,
Yes.
just could you quickly run over how you actually found out that angle, the angle alpha? Like, how do you know that? How do you know to take the modulus?
Well, I know that M2 is a negative gradient. M2 is negative, right? Because the line is going down, is sloping downwards. So I said I'm going to take the mirror version of that line, basically, which goes up with the same gradient, and find the arctan of that line, which is obviously the same as the bottom one. Is that making sense?
Oh, I see. So you just like pretended that it was positive, and then you could take the arctan of that, and that would have the same value. Oh, yeah, I see.
Yeah. So I took, this. Yes, I took the mirror version of that line, and pretended that it's a positive, and that made my life simpler. I could have done it, saying, well, because technically the angle is going to be that the arc M2 is the tangent of the line between the positive x-axis and the line. So it's this angle. This is arctan. This is arctan M2 without the modulus. But then it's just very complicated to figure out the angle alpha from here. It's not great. Do you see?
Yeah, I see.
Yeah. So this angle is it's just so much more hassle here. So many more places to go wrong. Whereas you can just say, well, what if this line was actually sloping upwards? That would be incredibly easy. So I find M2, and then I just add the values. Okay.
Thank you.
You're welcome. You're welcome. See you next week. Bye.